This is the Amp Hour Podcast, released June 21st, 2018. Episode 397.3. An interview with Jared Boone of Sharebrained.
Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
And I'm Jared Boone with Sharebrained Technology.
Welcome, Jared. It took nature to pin you down for an interview.
Yep, indeed.
We also have Peter here, former guest of the show, and so he's going to be heckling remotely while he installs a BBS server for the... What the hell are you doing? I don't even know.
Hey everyone. So
grinning like a Cheshire cat.
Yeah, right.
Grinning and criticizing.
Okay, great. Yeah. Well, just be typing away on that BBS server.
I will try to
right.
let you guys talk.
Okay, this is another interview from Tour Camp, and it's good to see you, Jared. So what's been going on? You've been pretty busy, huh?
It's mostly been manufacturing stuff. I hadn't quite bargained for the amount of work required to make porta-packs, but it's, this is the kind of problem that you expect to have or want to have.
Right, exactly.
Is not being able to keep up with.
Right, people want to give you their money.
And
Q-Fry meme, right?
Yep.
So what is the porta-pack for people who don't know?
The porta-pack is an add-on board. I like to just sort of call it a user interface add-on for the HackRF1 software-defined radio from Great Scott Gadgets.
Mm-hmm.
So the HackRF1 was originally conceived to connect to a PC, and then you'd use a PC to do all your software-defined radio stuff. Started out as GNU Radio, and then a whole bunch of other SDR software has grown.
Right, it's got that abstraction layer to basically allow you to have a software interface to it, right? It's all Python-based.
Yep. But you find that there's a lot of people out there that haven't really... They're really not connected with the whole open source community and building their own software, running Linux,
We
whatever.
just say GNU Radio on its own is enough to chase off any healthy-minded person, really.
Yeah, GNU Radio, it's extraordinarily powerful, but it has a steep learning curve, and I'm still going up the learning curve.
Well, we've had Derek on the show, Derek Kozel, who's one of the leads on that now.
Yeah.
And we talked all about that, and I made a couple jokes. I said I'd stop making fun of the interface and everything, too.
It's not a bad interface. It's just you have to really
you need to understand RF, right? It's like if you're learning RF through that,
and signal processing.
Right.
I got this block called a rotator. Well, what is a rotator?
That's a great question. I actually don't know what a rotator is.
So you're... this is going to be super
It's like phase
weird.
Rotation or something? Or?
Basically, yeah. You're taking a complex sample... chunk of spectrum represented in complex numbers. So you got positive and negative frequencies, which itself is kind of counterintuitive if you don't understand.
Right.
But effectively, you're taking a bunch of frequencies, and by using this rotator, you are giving them sort of a constant phase rotation in a positive frequency direction or a negative frequency direction. And the net effect is you're taking the spectrum coming in and shifting it by a frequency, a delta in frequency, determined by the amount of phase increment that the rotator is providing.
So you could do kind of like phase hopping type stuff then. And
no, it's for doing frequency translation. Like let's say you're sampling. A lot of software-defined radios have a DC spike or a LO local oscillator carrier induced spike right in the middle of the captured spectrum. And it really gets in the way of whatever signal you're trying to receive right in the middle of the spectrum. So if you tune off a bit and you shift that somebody humming.
Someone humming. I was like, that sounds like a bee. Yeah. Sorry, I'm very bad about bees. So
you got the spike in the middle. If instead you tune away, a couple hundred kilohertz or whatever from the signal you're intending to capture, then you can move that spike out of the way, capture the signal, and then when you want to do signal processing in the digital domain, you can use the rotator to shift back so that the desired signal is right in the center of the spectrum. And you can just low-pass filter instead of having to bandpass filter, which always requires more taps.
Oh, here we go. Question from the peanut gallery.
So I have a question because this is something not completely obvious for a lot of RF people, is why are you using IQ representation of radio signals?
It simplifies a lot of the signal processing. For one thing, I just sort of alluded to briefly, instead of having to do bandpass filters to pick out a channel-wide chunk of the spectrum you've captured, you can shift stuff so that you're centered on the signal you want, and then do a complex low-pass filter, and the math just winds up being easier. Also, certain types of demodulation and modulation processes are more easily done in the complex domain, just because you're dealing purely with amplitude or purely with phase, and that information is kind of lost if you're doing it in the real space.
Is it also related to the fact that complex numbers make it easier to deal with circles and rotations?
Yeah, and at the end of the day, things that are circular are oscillating if you squint at it the right way. A circle is kind of a representation of an oscillation.
Yeah. Awesome. Thank you.
There's certainly probably better ways to explain it, and for instance, Mike Osman's video series, which is kind of an embodiment of the workshops that he teaches at Black Hat every year. He goes into much greater detail with much better metaphors, including the use of a slinky to kind of demystify the whole complex number space.
Huh. So that was kind of a tangent on one of the things that you can do with that. So you're saying, though, that some people are not in that space yet. So then, does the PortaPack actually allow you to kind of step back and just use it in a practical manner? What is the ultimate goal of the PortaPack on top of this board?
There's, I guess, two things really. One is to address a bunch of use cases by making them very simple. You just plug in an appliance and it's ready to go immediately.
Yep.
And the other one is portability. So if you got your HackRF plugged in, PortaPack. Yeah, if you got your HackRF plugged into your laptop and you've got a bunch of software that you got to fire up and you fiddle with your touchpad or your track point or whatever,
right?
It's a lot to juggle. The PortaPack, well, it's still not attaining the ideal of a completely handheld device because you have to plug in a USB battery or some power supply.
Okay, but that could be like a brick, right? I mean, that could be like
you still got a cord.
Right. So you're not shipping with a lithium battery, but
I do not have the stones for that.
That's a healthy fear.
Yeah. I would like to do that maybe next iteration as I...
Or have a header so you could put one in there, but...
Well, little known secret is if you look at the newer generation PortaPacks, there is an entire layout for a battery charger
nice.
On the PCB.
Okay.
And also an external speaker.
I see you looking around. You know this is going to go out to people, right?
I do.
Okay, good.
Well, because I'm not shipping it, it's not a formal part of the product.
Right, of course.
So if someone wants to solder it up and... Yeah. The deal is that it was kind of, in a sense, an opportunity to prototype this.
Yeah, right.
It is not productized. There's no way to turn it off. So you plug in the battery charger and disconnect the USB power. The PortaPack will just keep running, and there's no way to turn off the power.
Yep.
So then what?
Yeah.
If you don't mind having your PortaPack just always running.
Yeah.
Attached to a battery, then you're cool.
Yeah. Okay. So
in theory, you could hack in a switch between the battery and the PortaPack, right?
It is an exercise for the reader.
Sounds like fun.
Could you explain what the PortaPack actually looks like for people who haven't seen it yet?
So it is a circuit board that attaches to the top of the HackRF. You wind up with this 2 circuit board sandwich that's about maybe an inch thick, roughly.
Okay.
And then that slides into an aluminum milled case that I have made in the U.S. Just because, I don't know, I like to think that we still make stuff in this country. And so you wind up with this really nice, solid chunk of kit that is about 130 millimeters by 80 millimeters, so about 5 by 3 inches and about 1 inch deep. And then all of the external connectors for the HackRF stick out. So you've got the clock input, clock output sticking out the bottom, USB connector. PortaPack adds a headphone input and output, and then you got the antenna and DFU and reset buttons and all the LEDs along the top side.
Cool. Well, speaking of noise floor, our noise floor is about to go up as a pontoon plane flies over, but I suppose
it sounds like a big, like a de Havilland Beaver or some. Yeah. Well, I suppose that would be a rotor.
What is APRS when you need it?
Right, exactly. So what are the capabilities?
ADSB.
What are the capabilities? So could the PortaPack track the transponder on that plane that's going over top?
Yep. So that's another thing about the PortaPack that I don't jump up and down and announce loudly, but there's a gentleman who goes by the name Furtek.
Okay.
who has taken my firmware and added a ton of really cool stuff, including a lot of sketchy transmit capabilities. So anyone who's interested in all the crazy things you can do with an SDR should definitely check out the PortaPack Havoc branch, HAVOC.
Okay.
So among other things, he has added ADSB reception and ADSB transmit.
Oh, okay. So that's like you could fake being a plane?
You can, but at 10 milliwatts, you're not going to convince anybody.
Well, you might if you're like in the plane, though.
Even then.
Don't do it, kids.
Yeah.
Recommended only for use in a laboratory or cable environment only.
Yeah.
But I think to some extent he developed the transmit feature in order to debug the reception feature.
Yeah, right.
So that's one legitimate use. Let's say you're developing an ADSB receiver. There's tons of them for RTL SDR dongles, and you now have a signal generator you can use for ADSB.
Right, and yeah, it's cheaper than paying a plane to fly over again.
Yeah, or I'm sure there's probably test equipment that's $100,000.
Yeah,
that produces very high quality ADSB signals.
Right.
Yeah.
So I remember you showed a demo of just like tire pressure sensors. That was a fun one. What was that? So like, what band is that? What is it transmitting on usually?
So the TPMS transmitters I have seen. So to rewind, tire pressure monitors are mandated in the U.S. as of 2008. The federal government requires it, and you find them attached to the valve stems on each of your four wheels. So as you're driving, you've got these little radio transmitters attached to each wheel, transmitting either in the 315 megahertz ISM band or the 433 megahertz ISM band. I should say I believe both bands are not universal across the entire world, and so you wind up with some manufacturers who use 315 in certain jurisdictions and some that use 433, 434. But it's really just either on-off keyed or amplitude shift keyed transmitters or FSK, frequency shift keyed transmitters, and they're about the same level of technical sophistication as a garage door opener or something like that. They're just transmitting these little tiny, typically 7 or 8 byte packets.
Right.
Half of the packet is just a unique identifier, so you don't wind up getting the flat tire notification from the car next to you at the stoplight.
Right. Why would anyone ever care about a unique identifier of a car as it passes by, right?
Well, my little sort of explanation for that is, it's basically like a web cookie for your tires.
That's crazy,
so
right?
You're not that I know of. I don't think there's any kind of database that links VINs with TPMS IDs.
Well, that's good.
And then, of course, once you have your tire replaced, usually you either get new IDs or I suppose they could reuse the sensors. I haven't really heard of that happening. But yeah, so there's no strong link between the IDs of your tire pressure monitors and we got dry ice bubbles.
Oh, another former guest of the show stopping in.
Yeah.
Joe Fitz, how you doing?
Oh, sorry.
Oh, it's okay. And we got some bubbles too, though. These are great. Are these ice bubbles?
Yeah, carbon dioxide. So we got dry ice in the bucket.
Very cool. Oh, wow.
We still need to hit these with lasers.
Yeah, right? That'd be great for a little laser game. Yeah.
I kind of assume they're going to light up like
right?
diffuse inside really well.
That's so cool. Can I pop one? Oh, the big one? Okay. This is great.
Yeah, so just fill a bucket with water, put dry ice in, and some rubber hose, and you dump it in the bubble solution.
That is so cool.
And so, unlike normal bubbles, they fall.
Right.
And
heavy bubbles.
when they pop, they
have little frosty,
cloud, like
right.
Dracula dissipating.
Nice. Well, thanks for showing us.
No problem. Enjoy the rest of your conversation, show.
Thank you. What were you saying about it? Sorry.
So on each wheel you've got these web cookies.
Oh yeah, right.
And you're driving around with a unique identifier that isn't necessarily indicating you, but with sufficient data mining.
Right. You take a picture of someone and you're like, well, there's that car
Take
again.
a picture or correlate it against E911 data being
or even just
collected in the
license
cell
plates,
networks.
right? I mean,
you can correlate LPR.
You could have like a camera with a little
you could
PortaPack
correlate line printer, license plate readers with TPMS transmissions as people drive by.
Right, and then you don't need the license plates anymore.
Yeah. The funny thing is, we're all driving around with our cell phones and our Bluetooth devices in our
Sure,
car
that's
anyway.
true.
So, TPMS is maybe not even the worst thing. But from an operational security standpoint, people who care about being able to go places without spitting out all sorts of unique identifiers need to know that
is out there, right?
tires are a concern.
Right. Yeah, that's true. So what are some of the other things that are on there? I mean, Peter, have you used this thing? Just seeing Jared use it over and over, yeah.
Well, okay, so there's some ham radio oriented stuff. There's a slow scan television transmitter, so you can load I think it's a ping file on there, and it will go and transmit a slow scan television signal. So you can do ham radio image transmission.
Yeah. I heard the Shady Tel folks were going to start transmitting, or no, sorry, on the LOL, which is the FM transmission.
Oh, they're going to do an SSTV transmission over the FM?
Over the FM band, yeah.
Nice.
Right. So they're like, if you know what you're listening to, you could go and do the back calculation.
Do they do that on a schedule?
I don't know.
Okay,
I just heard them
get a recording of that.
Yeah, kind of figuring it out. I don't know.
Okay.
The most I actually used the Portapack. I was visiting family in Poland next to the coast, and I was trying to receive transmissions from boats.
Oh, nice.
So that I did manage to get several transmissions, even though I feel like Portapack is not as a general purpose audio radio. It's more for the digital part of things. That's how I prefer using it.
Well, yeah, if you're going to do just sort of standard audio reception with the Portapack, there are better radios out there that are purpose-built for that. And I would just get that radio. If you want to do ham radio HF reception, get an AirSpy. But if you want to do a whole bunch of SDR experimentation, you want really wide bandwidth, you want something like the Portapack where it's completely portable, then it makes more sense.
Yeah, and I think the spectrum of all the digital transmissions these days, they are only getting more and more and more. Like earlier today, you were playing around with some ham radio digital modes, and this kind of stuff that lends itself for developing within the SDR domain. I think this is quite an interesting application for that.
Yeah, well, so we were at Dayton Hamvention. I was invited to hang out with the Great Scott Gadgets guys in their booth, and there were tons of people who had all sorts of different use cases. Like there was a guy who wanted to use the HackRF and Portapack as a down converter for a multi-gigahertz project that he was working on. I think it would make a great Whisper beacon. So Whisper is this really narrow bandwidth, low power signal propagation signal. So you set up a beacon and you transmit this Whisper signal out, and lots of other ham radio people are listening for it in various places around the world. And by nature of who receives it, you start to get a sense for how the atmosphere, the interaction of the
like
atmosphere and
almost,
space
right?
weather and all. Yeah. And so you have this kind of live view because everyone who's receiving these beacons is dumping the information onto the internet.
Right.
You're getting the sense of where the propagation is changing. If you want to jump on your HF ham radio
talk to Russia,
you know when is good because all these Whisper beacons are helping to figure that
crazy.
out live.
Yeah. Okay.
Let's see. What else does the Portapack do?
You should know. Well, and so you said that people can add stuff to it, though. Right?
Oh, yeah.
So it's open code base.
Yeah. So,
how many developers are kind of thrown in?
Well, it's just me and Furtek, and frankly, I haven't done a whole lot of firmware the last year because I've just been so busy trying to run the business in a sane fashion, like trying to get ahead of stuff. Because every once in a while I'll sell out for a month because I miscalculated when I thought I would need more inventory.
The thing about hardware is,
you have to make things.
Yeah.
Good problem to have, though.
Yeah. Right.
It is.
Yep.
So another thing that someone on his GitHub fork asked about this. What was it called? There are these jukeboxes, touch tunes.
Okay. Oh yeah, like the ones in bars where you can put $1 and get a song to.
Well, it turns out they have some sort of RF-based remote control.
Yeah. Sorry.
So they have an RF control that the people, the people who running the pub.
Right, when they want to switch over from paid to just playlist, right?
Yeah. And it's a very simple protocol, completely insecure.
Yep.
And, well, not completely insecure. Apparently there's a 3-digit code you have to type in for certain operations.
How would you ever get around that?
Yeah. So we were, me and the Great Scott Gadget people were at a Waffle House at Dayton Hamvention having breakfast, and
as one does in Dayton.
Somebody noticed, oh, there's a touch tunes, and so I ran out and got the PortaPack and started poking at the software, and we managed to turn it on and off.
Okay.
Without a pin.
Okay.
I think the other stuff requires a pin. But,
okay.
There are so many examples of radio technology that is insecure. But on the other hand, what's the threat model? Who does anyone care if some rando Dayton Hamvention nerds who have a lot of SDR skills walk into the Waffle House and start turning the jukebox on and off? Probably not.
If you were really digging Billie Jean and you put that dollar in, you might care.
Yeah.
But that's TVB gone for you.
Exactly.
Yeah.
Right. Yeah. Yeah, that's a good point. I think the idea though is that the on hand, like ready to go kind of thing. That's kind of different, right? It's not like get out all my gear. It's get out this one thing. And I assume that you're working on a wrist-based version at some point, right? A little radio hack wrist thingy.
I would like to. The PortaPack was basically sort of a half-baked product to begin with, in that the hack
You're not
RF
supposed
was.
to say that. We're recording again.
I know.
Just show you. Sorry. He's very open about it.
No, I go to great efforts to make sure people do not buy my product unless they really understand what they're getting.
Oh, okay.
And it grew out of the hack RF. It originally what happened is I think it was 2013 Maker Faire. I got this giant vacuum fluorescent display from Noritake.
Nice.
And I thought, I'm going to use this hack RF, and I'm going to modify the firmware. I'm going to do a bunch of live FFTs on it, and I'm going to stream out a live spectrum onto this VFD.
Yeah.
And so I took it down to Maker Faire, and people loved watching the spectrum. And I had this big jog wheel that you could tune back and forth across the spectrum, and I could show people cellular and Wi-Fi and broadcast FM, all that stuff. And then I began to realize, it'd be cool to just have this in my hand and be able to walk around and do spectrum analysis or whatever.
Yeah.
And so I just did a quick iteration, and I think it was the 2014 DEF CON that I brought it and was showing it around, and people got really excited.
Yeah.
And I think Osman took the HackRF Kickstarter live, I think during Black Hat that year.
Yeah.
And very last minute said, hey, you want to throw 50 PortaPacks in at the top tier? And I'm like, okay. And then I had to figure out how to actually make it a reasonable form factor. And so in an ideal world, it wouldn't be 2 circuit boards. It would have a battery.
Yeah.
There's all sorts of stuff I would change about it.
Right.
And I'm hoping at some point to get to that.
Cool. Well, I'm sure that people listening might have suggestions or offers of help or whatever. Yeah. That's cool. That's the kind of thing where it's like it serves a need that sounds like it's there and it's been proven out. So I think it's really a question of like not specific to this project, but just in general too. It's like it's not about does this one work. It's just like how big, like how much time should you put into it. Like how big is the ultimate audience of people that need on hand spectrum analysis, and it's like somewhere between your product and like what are those Agilent handhelds that are like $20,000? Like the
That's definitely a lofty goal, but for a lot of use cases, you don't need the calibrated precision of devices like that.
Yeah, I think you're right. It's a new chapter of hardware, right? It's like somewhere between high-end test equipment and a piece of wire. That's great. So what is the actual what's like the processor that's on board and what's running so it's a display, it's a turn wheel still.
Yeah, so that's another thing. In fact, I probably should improve the documentation because every once in a while people don't quite get it. The navigation wheel on the front is it's 4 axis or 4 arrow keys, so up, down, left, right.
And
then there's a kind of middle ring which rotates left and right. It's an encoder. And then there's a select button in the middle. Yeah. And so sometimes people will get it. They haven't really read the instructions.
I assumed it was kind of like old iPod style. That's kind of what it looked like to me.
It kind of works in a similar fashion. Yeah. It's not like a CapSense sort of thing. Mm-hmm. Although I guess the really old iPods weren't capstents either. They were mechanical.
Oh, they were?
Yeah. I never had one.
Okay. Yeah, I never did.
So yeah, you got the control wheel, you got LCD panel, you've got a resistive touchscreen, which everyone expects a really light touch because of smartphones now, and so having a resistive touch display it doesn't really meet people's expectations, and so that's another thing I'd like to improve. And then you've got the audio
pen with it, and it's like it works great for typing in some numbers since I get to a frequency quickly. It is useful to have.
Yeah.
Oh, I don't deny having touch is useful. It's just that resistive touch kind of blows compared to capacitive touch
Sure, but
sensing.
there's quite a significant
there's a
price
step up,
difference too, and it's a step up to it.
Yeah.
What is the cost of the whole thing together?
PortaPack is presently $220 US, and then the HackRF I think is retails $300 US.
Got it. So you got to just put it together yourself though and everything.
Yeah.
Okay. That's good though. I mean, I think that also kind of gives the feel of I'm putting this together myself. There's some expectations with that, I think, too.
Yep.
Yeah.
Although I would like to, again, get past that at some point.
Sure.
Where people don't have to go and flash firmware on it, and I don't have to maintain flash installers for 3 different operating systems.
Right. Okay, so what is the micro that's on board? You said there was...
Oh, so it's a Parasite. It's using the HackRF processor.
Oh, okay.
Which is pretty beefy. It's a LPC 4320.
Right, yep.
So it's got 200K worth of RAM, which for a microcontroller is not bad.
Yeah.
But it's 204 megahertz ARM Cortex M4 with hardware floating point, plus an M0 running at the same speed.
Got it.
So you've got this heterogeneous multi-processing environment.
Right.
So,
but it's all embedded still. Is it bare metal or no?
Oh, yeah. Well, technically there is a
RTOS.
layer of ChibIOS.
Okay, yeah.
And I don't know why I went with ChibIOS over FreeRTOS, other than it was just an aesthetic choice. ChibIOS just felt better to me, but I know lots of people use FreeRTOS.
Yeah, and what are the new ones too? Like Zephyr is a new one, and Minute was the other new ones.
Yep.
Yeah. I get these glimmers of this stuff by hanging out on the Embedded FM Slack, and I'm like, oh yeah, look at these new things. Look, I know all about these. I don't know anything.
Well, for better or worse, I'm really frustrated with using the whole C language.
Generally?
Yeah.
Yeah. Screw that stuff.
I'm getting hooked on Rust, but
really?
I haven't had a whole lot of time to really develop my skills in Rust. I have done some basic bring up of a user interface layer. I'm not accustomed to talking this much. So yeah, I'm learning about Rust, and I've done some basic user interface stuff, rendering library, just drawing rectangles and various stuff, and getting really good performance out of it. But I haven't gone too far because I figure I've got a code base that works.
Sure.
I can just sort of hold my nose, maybe try and make my code better in C and C++. I just find that C++ in particular, the feature set is so broad, and yet the language design, at least through the 90s, a lot of the features introduced then were definitely a double-edged sword, where you would use it and you'd wind up with code that in some ways was maybe almost less maintainable than if you'd just done it in kind of a C style.
Yeah, right.
So I'm trying to find, I've always been trying to find the right place in C++ where I'm using just the features that are really benefiting the code base and making really readable, maintainable code without going too far and making just a horrible cruftball.
So the stuff that you're writing though, you pull in all the HackRF low-level stuff, and then
it's
right on top of it. How does that work?
Started from scratch.
So you don't have parallel development though with the actual the actual stuff that's talking to the radios on board
is my own C++ implementation.
So why did you do that?
Because I found that the C API, such as it was back then, wasn't really very well designed for portable use. It was much more designed to be tethered to a PC and dumping stuff over USB.
Oh, interesting. Okay. So that makes sense then. I was just thinking about the low level, interacting with the registers that are on the front end chips. That's what I was thinking about.
Yeah.
So you had to re-implement all that stuff though.
Yeah, but I wrote a great deal of the first implementation too.
Bingo. All right.
The big contribution from Jared is the libopen CM3 support for the LPC part. It's LPC support.
Oh well, yeah, I did a bunch of headers, but then Osman and I spent a bunch of time trying to figure out what hardware platform we would use at a very basic level, because we wanted USB 2 high speed performance, because an SDR that ran at full speed isn't very useful. It was nowhere near the design goals that we had.
And that's just because of the streaming capabilities you're saying, of like getting data back into the computer.
Yeah, we wanted to be able to get to 40 megabytes a second.
Got it.
And we did look at, FPGAs were entertained for a brief period of time, but they're really not, certainly not in 2012. They were not very open at all.
Right.
And now they're just barely open thanks to
Ice-40
Clifford and the whole Ice Storm, Yosis, etc.
Another person Peter introduced us to, introduced to Clifford, so Clifford's been on the show, so that's been good.
Right on.
Yeah. So pretty much I only know one group of people, and I'm sitting with a bunch of them, and it's good.
Well, it seems like a good group.
It is a good group to know, yeah.
It's the group I seem to prefer hanging out with.
Yeah, right.
So, apropos SimpliFlow, I wanted to drop it in. They are also working on further FPGAs that are coming to be supported, not just with the Yosis Arachne PNR setup, but anyways.
So for another show, we'll get you and Tim on and talk about that crap, huh? Yeah. I'm like so out of my element when I hear about that stuff.
Tim's not here.
Tim Ansel, no, I don't think he is.
No, he's got a lot of projects.
Yes.
In fact, I think trying to emulate him.
I think first couple of slides at Teardown were basically I have too many projects.
Oh, that's all he said on the show too when he was on.
Okay,
so,
yeah. It's cool. It's good to aim high.
It is good to aim high.
I sometimes think I err the other direction.
Yeah. Oh, well, we'll call you up and be like, Jared, do some more stuff, huh?
Right, okay.
Yeah. Come on. What are you doing? Hey.
Slacker.
Yeah, right. Awesome. Well, where can people find out more about your stuff?
So website is Sharebrained. A lot of people hear it as Shared Brain, but it's Sharebrained, like hairbrained with an S on the front to make it open source.
Too clever.
Well, so my wife and I, we spent a whole day, some weekend, I guess 11 years ago, trying to figure out the name for my company. And we kind of had a mission statement, what was the point of the company, and did a whole bunch of brainstorming and just started sticking words together, and eventually Sharebrained.
Nice. That's a good way to do it.
Yeah. People still don't hear it right or don't remember it right. But, any product name you pick, people will mix things up.
That's why Google's around.
At Hamvention, people will say the Hacker One or the RF Hack.
Right.
Just because it's just sort of a string of letters to them. They haven't been saying it for 7 years.
All you have to do is just get all the misspelling domain names.
There you go. Right.
Cyber Squad on all the all the oopses.
Yeah. Well, awesome. Thanks for talking to us, and we'll post some links to all the things you're talking about.
Okay, right on.
Thanks.
Yeah, thank you.